Hey guys, so this is just this week's video for our grind. So I'm just going to run through questions we did during the week. Same as always, if you have any questions, um, let me know, and if I forget any, let me know and I'll do them again. Or if you have any exam papers you've been doing yourself and you've been struggling with, let me know and I can go through them. But yeah, let's jump in straight away. So we just had a bit of surds we did at the start, so let's quickly run through these. So the main idea with these is to get the square root on one side and everything else on the other, and then square both sides and get rid of the square root. So let's just jump right in. So let's get started on number one. So like we were saying, we're going to get just the square root on one side and everything else on the other. So I'm just bringing that one across. Now if we square both sides, so if I square both sides like this, now we have to be careful when we're squaring things that are added together, like we were saying during the week. So squaring can't jump over, say, this sign here. So you can't say that that's x squared minus 1 squared, because you'll be missing a term. Because we know if we're squaring something like this, we want to square the first, that's x squared, 2 times then multiplied together, so that's minus 2x, and then 1 minus 1 squared at the end is just plus 1. If I were to, actually I'll leave that there. If I were to say that we could jump this to here and here, and so that was equal to x squared minus 1 squared, which is equal to x squared plus 1, you can see that we're missing this minus 2 in the middle. So you just have to be careful when dealing with things added together that are squared, things added or subtracted together. So yeah, so we'll just go ahead and do that like we know. So the right hand side, that's square the first, that's x squared, 2 times then multiplied together, that's minus 2x, and then minus 1 squared at the end, that's just plus 1. Now if we do the left hand side, we know that our square root will just cancel with our square because they're kind of like opposites, and we're left with just whatever's under the square root sign. So that's 3x minus 5. Now we can see there's no more square roots, so we can just bring all our x's to one side and solve for x from there. So if we have x squared minus 2x, if we bring this 3x across, that's minus 3x plus 1, and we bring this 5 across, that's plus 5. And so all that's equal to 0. So that's x squared minus 5x plus 6 is equal to 0. I'm just moving that same thing. It's a 0 over here. Now we want to solve for x. So how we're going to do that? It's quadratic, so we're going to factorize and then turn the factors into roots. So quickly factorize, and that's x, x, 3, 2. So yeah, sorry, I'm skipping steps. Just to run through again how I factorize. I know you guys do it a different way, but hopefully if you keep seeing me doing it this way, you might think it's easier. I might do it that way if you want, or stick with the way you're doing it. The way I do it, draw a big X, get the factors of X, that's x squared is just x times x. 6 is just 3 times 2. And then to get to minus 5, we want to do minus 3 minus 2. And you can see that minus 3 times minus 2 is plus 6 as well. So it all works out. So then you just take a look at these, and these are your factors. So that's x minus 3 times x minus 2, and all that's equal to 0 because this is equal to that, and that's also equal to 0. Now, if both of these are equal to 0, at least one of them has to be equal to 0, so we'll do our special trick of splitting them up. So if x minus 3 is equal to 0, that means x is equal to 3, and if x minus 2 is equal to 0, that means x is equal to 2. So we have two answers for x, but we're not finished. Like we were discussing during the grind, your teacher could take marks off you for not checking solutions, or exam papers might not take marks off you for not checking solutions, but you need to know which solutions are the real solutions, because one of these might not work due to the square root, and you might end up with a minus square root, or something that kind of throws it off. So you need to know that you need to know which answer is the right answer, and then submit that as your final answer. So yeah, what I'll do is I'll just copy paste our original equation, but you would sub in, wherever you see x here, you'd sub in your value for x, so that's 3. So that's 3 times 3 minus 5 plus 1 equals 3. So that's 9 minus 5 plus 1 is equal to 3. That's square root 4 plus 1 is equal to 3. So that's 2 plus 1 is equal to 3. So that's 3 equal to 3. That works. 0 equals 0. What I've done there is just 3 minus 3 equals 0, and then 0 equals 0. Sometimes it's easier that way if you want to finish it out like that. Doesn't really matter. 3 equals 3, we know that works. So x equals 3 is a solution. So then if we sub in x equals to 2 now, that's 3 times 2 minus 5 plus 1 is equal to 2. So that's 6 minus 5 is equal to plus 1 is equal to 2. So that's root 1 plus 1 equal to 2. Root 1 is just 1 because 1 times 1 is 1. So that's 1 plus 1 is equal to 2. So that's 2 equal to 2, and that works. So x equal to 2 is a solution. So yeah, both these answers work, and these are your answers to the final question. And so that's question 1 done. And so we'll move on to the next question. So next question, we see here we have 2 square root signs. So we know it's a bit different from the first one we had where we had 1. But we know that if we square this and square this, if we square it, it's going to get rid of that square root sign. If we square this one, we have to make sure we can't jump this 2 across that plus sign. So it can't be square that one and square that one. If we could do that, it would get rid of both square root signs at the same time. But like we were saying before, we're going to be missing a term in the middle here if we jump that 2 in. So we have to make sure we don't do that. And we'll see that we still have an extra square root sign after we square everything. But anyway, let's just get started. So, yep, we're going to square both sides. 3x minus 2 squared equals to x minus 2 plus 2, all to be squared. Left-hand side, we know that cancels with our square root, so that's just whatever we have under our square root sign, so that's 3x minus 2. Now here we have to be careful. We're going to treat this like we would any other x plus 1 to be squared. So what do? We square this 2 times, then multiply together, and then square the last. So same thing, we're going to square this. I'll just write it all out just to make it clear. So we're going to square that, then we're going to add 2 times, then multiplied together. So then multiplied together is just the 2 in front. And then we're going to square this last one, so that's just 2 squared, so that's just 4. Then tidying this up, we know that our square root sign will cancel with our squared. So we're left with x minus 2. These 2's will just multiply together to make 4 times x minus 2. And then we have the 4 at the end. So you see what I was saying about there's still going to be an extra square root sign in the middle that we would have missed out on if we had just jumped that 2 in. So we have to make sure not to do that. So let's just tidy everything up. We still have this square root sign, so we're going to get that on its own, and then we're going to square both sides. So get that on one side and all the x's and the numbers on the other. So let's bring these across. That's 3x minus x. That's minus 2 plus 2, and that's minus 4 is equal to 4 times x minus 2. We know minus 2 and plus 2 is equal to 0. 3x minus x is 2x. Minus 4 is equal to 4x minus 2. If we square both sides, that's 2 minus 4 squared is equal to 4 root x minus 2 squared. So here we not need to follow our rule. We're going to square this first one, twice the product, and then square the last. So we're squaring this first one. That's 2 squared. So squaring 2x squared, then add 2 times minus 4 times 2x, and then add minus 4 squared. So I've just written everything out just so it's kind of clear. We know on this right-hand side, we can just square everything. So 4 squared is just 16, and root x minus 2 squared, we know that square will just cancel. So on the right-hand side, we have 16 root x minus 2. And on the right-hand side, we need to do a bit of tidying up. So 2x squared is just 4x squared. And this 2 can multiply in with that 4, and then multiply again with that 2. So that's minus 16x. And then minus 4 squared is plus 16. And so 16 root x minus 2. Sorry, that square root is gone. We can see we can divide everything by 4 straight away. So that's x squared minus 4x plus 4 equals 4 times x minus 2. So that's x squared minus 4x plus 4 equals, and I'm just going to jump this 4 in, so 4x, and then minus 8. And now we're going to bring all our x's to one side, so that's x squared minus 4x minus 4x plus 4 plus 8 is equal to 0. So that's x squared minus 8x plus 12 is equal to 0. So factorizing, that's x times x is x. 6 times 2 is 12, and we want negative 8, so that's minus 6 minus 2. And then we know that works because minus 6 minus 2 is equal to plus 12. And so these are our answers. These are factors. And the only way both of them multiplied together equal to 0 is if one of them is equal to 0. So it could be either of them. So we'll let them both equal to 0 and see what we have. So then that's x equals 2. And so same as before, we're going to check our answers. So if I go up and copy this, just to make sure both of them work, because some of them might not because of the square root. So if we throw in 6 for x, 3 times 6 minus 2 is equal to 6 minus 2 plus 2. That's 18 minus 2 is equal to 4 plus 2. So that's root 16 is equal to 2 plus 2. That's 4 equal to 4. So that works. So x equals to 6 is a solution. Then we're going to check x equals to 2. So we'll throw that in for x. So that's root 3 times 2 plus minus 2 is equal to root 2 minus 2 plus 2. So that's 6 minus 2 is equal to 0 plus 2. So that's 4 equals 2. So that's 2 equals 2. And that works. 0, square root of 0 is just 0. So that's 2 plus 0, which is 2. So that works. So x equals 2 is a solution. So they're both solutions that work. And our question is done. These are our answers, x equals 6 and x equals 2. So we did them during class, so there should be no issue with them. But I'll just move on to these next two and see what they're like. So this one seems easier. We have just one square root. So we're going to do like we usually do. We do minus 2, 7x, and just bring this 2x across. So that's minus 2x. Square both sides. 2, 7x squared is equal to minus 2x, all to be squared. Square root will cancel with that square. So that's 2 minus 7x. Minus 2 squared is 4. X squared. Bring everything to one side. Minus 2. So 0 equals that. We're going to factorize. So 2x times 2x is 4x squared. 2 times 1 is 2. And so 2 times 2 is 4. That won't work. Oh, 4 and 1, say. And we're going to do it this way. So 4 times 2 is 8, and we need to get, so that's plus 8, and then we need to take 1 off to get back to 7. So these are our factors. 4x minus 1 times x plus 2. Well, that's equal to 0. Same thing, split them up. 4x minus 1 equal to 0. X equals to a quarter. X equals to minus 2. Let me just check that works. 4x squared minus x. Yeah, that works. So now we're going to check our two answers and see if both of them work. And I threw this question in. You'll see why in a second, because it looks easier than the second question, but you need to make sure your answers work. So if we throw in a quarter for x, 2 minus 7 times a quarter plus 2 times a quarter is equal to 2 times 7 over 4 plus this 2 cancels with that, and you're just left with 2, so that's a half, equal to 0. Can't forget that. 2 can just be written as 2 times 4 over 4, because 4 over 4 is just 1. So if we rewrite that as 2 times 4 over 4 minus 7 over 4, we can subtract one off the other without any problems. So 2 times 4 is 8, so that's 8 minus 7 over 4 plus a half equals 0. So that's 8 minus 7 is 1. Root 1 quarter plus a half equals 0. So same thing when you're squaring a fraction, you square the top, square the bottom. Same thing when you're square rooting, you square root the top and square root the bottom. So that's 1 squared over, or root 1 over root 4 plus a half. So that's 1 over 2 plus 1 over 2 is equal to 0. So that's 1 equal to 0. So obviously 1 can't be equal to 0. So x equals to a quarter is not a solution. And we'll just check our other one. So x equals minus 2. Root 2 minus 7 times minus 2 plus 2 times minus 2 is equal to 0. That's root 2 plus 14 minus 4. So that's root 16 minus 4 is equal to 0. So that's 4 minus 4 is 0. That's 0 equals 0. So that one does work. So x equals minus 2 is a solution. So I include this one because you can see only one of them is a solution, and that's x equals minus 2. So we can disregard this one up there. And so x equals minus 2 is your final answer. And finally, on to the last question. Here we see we have two square roots again. So we're going to have to end up squaring twice. So what we'll do is we will get one on one side and one on the other. X plus 1. So we're going to square both sides. That's 5x plus 1 squared is equal to 6 minus x plus 1 to be squared. Your square just cancel. So that's 5x plus 1. Now we're going to do the exact same thing. We're going to square this 2 times the product, square the last. So we're going to do 6 squared is just 36 plus 2 times 6 times minus x plus 1. Sometimes it helps if you write it all out. And then we're going to add minus x plus 1 to be squared. So that's 36 plus, we can half that 2 in, that's just 12 times minus root x plus 1. And then our square root will just cancel, and any minus squared is just a plus. So that's plus x plus 1. So that's 36 minus 12x plus 1 plus x plus 1. And all that's equals to 5x plus 1. So we can see we're on the right track. We only have one more square root left to deal with. So let's do that. Let's get it on its own. So let's bring this across and bring these two across to the other side. So that's 12 root x plus 1 is equal to 36 plus x plus 1 and then minus 5x minus 1. Let's just tidy everything up a bit. So that's 12 root x plus 1 is equal to 36 minus 4x. And we're just going to square both sides. So that's 12 root x plus 1 to be squared is equal to 36 minus 4x squared. So 12 squared is 144. Our square root will just cancel. So 36 squared I think is 1296. Let me just check that with my calculator. Sorry now. So 36 times 36 is 1296. Yep, I was right. So then we're going to add 2 times 36 times minus 4x, and then minus 4x squared is just 16x squared. So we can tidy all this up. So that's 144x plus 144 is equal to 1296. We're going to multiply this in, so that's 72 times minus 4x plus 16x squared. So 144x plus 144 is equal to 1296 plus 72, or that's going to change to a minus. 72 times 4 is 288x, and then 16x squared. So I think let's just simplify everything first. So we're going to bring these across to the other side. So that's 16x squared, and I'm just going to write our highest power of x first, like we always do. Minus 288x minus 144x plus 1296 minus 144. So that's 16x squared. 288 minus 144 is, that's minus 288 minus 114, so that's minus 432x, and 1296 minus 144 is 1152. So if I've done all my calculations correct, I think these should all be divisible by 16. Minus 432 divided by 16 is 27, yeah. 27x, and 1152 divided by 16 is 72. So how are we going to do this? X is probably factors of 72 divided by 8. So, 3 and... So what I was doing there was just dividing 72 on my calculator by different things and see what would add up. So 3 and 24 obviously give us 27, and we want minus 24. Sorry if that'll... or erase. There we go. So we want minus 24 minus 23 is minus 27. So x minus 3 times x minus 24 is equal to 0. Split them up. X minus 3 equals 0. X equals 3. X minus 24 is equal to 0. X equals 24. And we're going to check if those are right, like we've been doing the whole time. So I'm going to copy this. Going to paste that. Going to sub in 3 for x. So that's root 5 times 3 plus 1 plus root 3 plus 1 is equal to 6. So that's 15 plus 1 plus 3 plus 1 is just 4. It's equal to 6. So that's 16 plus 2 is equal to 6. So that's 4 plus 2 equal to 6. That's 6 equals 6. That works. So x equals 3 is a solution. Now we're going to check 24. So 5 times 24 plus 1 plus 24 plus 1 is equal to 6. 5 times 24 is 120, I think. So I got that wrong. No, that's 120. Root 120 plus 1 plus root 25 is equal to 6. So that's root 121 plus 5 times 5 is 25. 11 times 11 is 121. So obviously 16 is not equal to 6. So x equals 24 is not a solution. And so that's your question done. We can get rid of this x equals 24, and we see that x equals 3 is our final answer. So those are our 4 examples of surd questions. You can see there's really only kind of 2 types. You have the one with the with the 1 square root, and then you have the other with the second square root where you have to square twice. And just make sure to check your answers at the end. Yeah, so we'll move on to our next topic. So we're just going to take a look at some graphs next. We ran through them a little in the grind, or we ran through them in the grind, but I'll just run through them a little again here, just as a refresher, and then we'll jump into the sketching. 2 basic things when you're thinking about graphs is positive or negative and odd or even. And what we mean by that is, take this one, for example, here. This is a quadratic equation. So this is something like that, x squared plus 2x plus 1. We know that it's positive because this sign in front of our highest x is positive. And we know it's an even order because our highest x is even. So x is raised, the highest thing x is raised to is a 2, and that's even. And the sign sitting in front of the x is positive, so we know the curve is positive. We know that positive curves, we know that even curves will both finish on the same side, and positive even curves will both finish up. If we went over to this one, for example, this could be minus x squared plus 2x plus 1. This leading coefficient, this leading sign of x is negative, so we know it just flips everything upside down. We know it's still a quadratic, and we know it's still even, it's 2. So we know they'll both finish on the same side, but this time it's odd, so they'll both finish down. And we can go into things like, we know it's a quadratic, so it crosses 2 times. Here, when we were talking about 2 times, that's obviously it's bouncing, so it's crossing and crossing again. And you can see that because, this is actually just the curve x squared. So that's x plus 0 to be squared. So you see that x plus 0 is your factor, 0 is your root, and you know it bounces off it because it's repeated. So it'll cross and cross again. But we'll get into that in a bit. Two things I just want you to remember is this is positive. The leading sign in front of the highest x is positive, and it's even. Highest x is even. So even, finish on the same side, positive, both pointing up. Think of positive as up, it's good. Negative, both pointing down. Even, both pointing the same way. Because we can move on then. And this, for example, is a cubic, so this could be x cubed plus 2x squared plus x plus 1 or something. We know this is positive. The leading sign of x is positive, and we know it's odd. The highest x is 3. So odd functions finish on opposite sides. And if it's positive, it finishes up. Think of up, it finishes good, it finishes positive. But because it starts and ends on opposite sides, it's because it's odd, this one has to start from down. So odd functions finish on opposite sides. Think of that. Odd functions, opposite. And this is positive, so it finishes strong, it finishes positive. So it's odd. So it'll go up here, and it'll finish the opposite side, but it'll finish up. So that means it must start down here. If we go across over to here, this is something like x minus x cubed plus 2x squared. I'm just making these numbers up. Plus x plus 1. We know that it's odd, so they're going to finish on opposite sides. We can see that. And we know it's negative. Think of negative bad as down. It finishes down. It finishes negative. But if they're starting on opposite sides, that means this one has to come from above. Because it's odd. Odd, opposite, negative, finishing down. We can keep going then. This is the next one up. So this is like an x to the power 4 plus x to the power 3 plus x to the power 2 plus x plus 1. Something like that. Doesn't really matter what it is. Highest power of x is even. So they're both finishing on the same side. You can see that. Leading sign of x is positive. So they're both finishing up. They're both finishing positive. Now if we look at over this is minus x to the power 4 minus x cubed plus x squared plus x plus 1. Doesn't really matter. Like this could be a minus at the end as well. As long as this leading x is negative, that means they're both going to finish down. And highest power of x is 4. 4 is even, so they both finish on the same side. Both finish negative. They both finish down. And even, the same side. If we were to sketch number 1, how many times does it cross the x-axis? 1, 2, 3, 4, 5 times. So we know this is going to be something like x to the power 5 plus x to the power 4 plus blah, 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 blah. So we know it's going to cross 5 times. So our highest x is 5. So if we drew a little sketch, and we know it's going to cross at minus 3, we're going to change the signs. Minus 3, minus 1, plus 2, plus 5, and plus 6. So minus 3, minus 1, 2, 5, and 6. So leading sign of x is positive. So we know it's going to finish up. It's positive, it's going to finish up. Highest power of x is odd, so they have to start and end on opposite sides. So we know we're going to have to start from below. And we know we're going to have to pass through all these points where it crosses the x-axis. So if we're starting low because it's odd and we want to finish high, and we want to finish high because it's positive. So we're just going to, doesn't really matter what you do. And then through 6. There you go. That's just enough of a graph that you need. Now you can, you're going to want to throw in, if x is equal to 0, you're going to want to just, that's 0 plus 3, 0 plus 1, 0 minus 2, 0 minus 5, and they're all multiplied together. So that's 3 times 1 is 3, times minus 2, minus 6, times minus 5 is 30, times minus 6 is 0, 180, minus 180. So because x is 0, you're on the 0 x-axis. plug in 0 for x, and you get where it crosses the y-axis. And that's how you're going to graph your function. So if we take a look at number 3, say, 1, 2, 3, we have minus x times x plus 4 times x minus 2 times x minus 3 to be squared. Now, we were talking about this before. You see this repeated factor over here. That means we're going to have to bounce off an axis. And you can think of this minus x as just minus x plus 0. X plus 4, x minus 2. And you can think of this square as just itself multiplied by itself. So how many times does it cross the x-axis? 1, 2, 3, 4, 5. Is that odd or even? 5 is odd. So we know they're going to finish on opposite sides. What way is it going to finish? You can see that this x here is negative. So it's going to kind of turn all these x's. It's going to turn at least one of the x's negative, and it's going to be the highest part of x, basically. Because this is going to multiply by all these x's and turn the first x negative. So we know it's negative, and we know it's odd, so it finishes on the opposite side. So if it's negative, it's going to finish down. It's negative, it's bad. And if it's odd, it's going to start and finish on opposite sides, so we're going to have to come from this way. So we're going to plug in where it crosses first. So minus 4, 2, 3, and 3 again. And don't forget 0. So we're going to come from up here, and we're going to pass through all these points and then finish down. So there, through 0, 2, and we know we're going to bounce off 3 because it's 3 times 3. So think of that like crossing, crossing again. And we're going to sub in, well, we know it already crosses the, and why does it cross? Sorry, I'm tripping over my words here. What we did in the one above is we subbed in 0 for x, and then we multiplied it all together. If we did the same, we'd see that we'd subbed in 0 for x, and it would just multiply everything by 0, so it's going to cross at 0. But you can write it all out if you want. You can sub in, so it'd be 0 plus 0 times 0 plus 4 times 0 minus 2 times minus 3 times minus 3, but this 0 is just going to turn everything to 0, so you're going to cross at 0. So that's our third one done, and why don't we do our 1, 2, 3, 4. Why don't we do the last one? Number 8. So that's minus x, x plus 3, x plus 4 to be squared. So think of this x like x plus 0, x plus 3. This repeated factor is going to be x plus 4 times x plus 4. How many times does it cross the x-axis? 1, 2, 3, 4. Is 4 even or odd? 4 is even, so we know they're going to finish on the same side. Is the whole thing positive or negative? The whole thing is negative because of this negative x. You can see none of the rest of them are negative. So where are we going to cross the x-axis? We're going to cross at minus 3. We're going to cross at minus 4. And we're going to cross at 0. So what did we say? We said it was 4, so it was even, so they're both going to finish on the same side. And what side is that going to be? It's going to be negative, it's going to be down, so they're both going to finish, this is going to finish down, and they're both going to start at the same side. So we're going to want to come here, come through minus 4, through minus 3. No, we're going to want to bounce off minus 4. See, you can get confused here. There's two 4s, so we're going to want to bounce. Then we want to go through 3 and then down. And that is our curve. You can see again, if we sub in 0 for x, we're just going to cross at 0 again, so we don't need to worry about that. And they are your graphs. If you need me to do any more, let me know, and I'll do them in the next grind, because it's really useful just to kind of help visualize things, even if it's not the question you're asked. really helpful to figure things out, like we'll see in the next section. So, moving on. So, on to the last part, and this is completing the square, or I call it vertex form, just the same thing, doesn't really matter. And what this is just purely a different way of writing quadratic expressions. So they're the same expression, same curve, same function, whatever you want to call it, just a different way of writing it that gives you a little bit more information about the critical point. And so that's the point where the function turns. So we know that every quadratic equation can be written in this form: x minus k to b squared plus p. Doesn't really matter what these are. I think your teacher uses different letters, but it doesn't really matter. So every quadratic function can be written like this, and so we should be able to write this like this. Now, your teacher has formulas and stuff for doing it. They're all a bit messy. You get lots of letters, lots of signs that you can trip up on. My way is the exact same way as her, but just minus the equations. So it's the exact same technique, but it's just streamlined. So what we're going to do is we're going to take this middle one, divide it by 2. So 12 divided by 2 is 6. We're going to square that, square the first, that's x squared, plus 2 times, then multiplied together, and then square the last, that's 36. So that's x squared plus 36x plus, 12x plus 36. And how are we going to turn 36 back into 32? All we're going to do is minus 4. And we know that we just multiplied that out, so that's the same thing. We just did that. So that's x plus 6 to be squared minus 4. And that's your answer. It's as easy as that. And so these are the exact same curve, just written in a different way. And why you're going to do that is because if you have it written in this way, x minus k squared plus p, your critical point is going to be kp. So the critical point of curve is, like we were saying, if it goes here, it's where it turns. And if it was negative, it'd be like this. So up here, that would have coordinates kp, kp. So what's k here? Well, minus k here is plus 6. So minus k is equal to plus 6. So k is equal to minus 6. And that's why you have to change the sign of the one in the middle. So then what's p here? That's negative 4. So the coordinates are minus 6, minus 4. These are the coordinates of our critical point. So for our specific curve here, it would be minus 6 over here somewhere and minus 4 down here. And it would go like this. So this is minus 6, minus 4. This is our critical point. Now, I've already drawn the graph, but is it a maximum or minimum? You can see here it's a minimum because I've already drawn the graph. How did I know to draw the graph that way? Well, that goes back to what we were doing. It's even, so they both finish on the same side. And what side do they finish on? Well, they both finish up because it's positive x. And so that's how you know if they both go up here, the turning point is going to be at the bottom, so that's going to be a minimum. If it was the other way around, if it was a negative quadratic, it would turn, this would be the highest point, so that'd be a maximum. But this one here, minus 6, minus 4, is a minimum point. And that's your question done. So we'll just move on to the next one. What we're going to do here, same thing, take the middle one, divide by 2, x minus 4 squared, that's x squared 2 times, then multiplied together is minus 8x, and then 4 minus 4 squared is 16. How are we going to turn 16 into 12? Well, we're just going to take 4 off it. And we just did that part, we just multiplied it out, so that's the exact same thing, that's x minus 4 to be squared, and then minus 4. And that's your answer done. Now, if they were to ask a second question, what's the critical point? You know your critical point is kp, and it always helps if you forget to write this out, just to help with the sign. What's minus k here? I get my red pen. What's minus k? is minus 4. So minus k is equal to minus 4. So k is equal to 4. And what's p here? P is minus 4. So if we were to write kp, we would write 4 minus 4. And that is our critical point. Is it a maximum or a minimum? We can draw the graph. How are we going to draw the graph? Well, we know it's even, so they're both going to finish on the same side, and it's positive, so they're both going to finish up. And where is it going to turn? It's going to turn at 4 minus 4. So somewhere there, and it's going to go. So that's the point 4 minus 4. And that is our critical point. It's the lowest point, so it is a minimum. That's your question done. Now, next question. Surprised I didn't get a WhatsApp about this because I threw it in to throw you off. So if we're doing it my way, what you do is take this middle one divided by 2, minus 2 squared. That's x squared minus 4x plus 4. And then we're going to add 1 to get to plus 5. So that's x minus 2 squared plus 1. But that's not right. You'd be wrong. So what you've forgotten about here is you've forgotten about the 2. I'm not saying you guys did this, but this is just a common mistake. Common mistakes are forgetting the 2 at the start and forgetting it at the end. So what I mean by that is what we're going to do is just take this 2 out and then multiply it back in at the end. So what I've done is just take out the 2, so divide everything by 2 basically. So 2 times x squared is 2x squared. 2 times minus 2x is minus 4x, and 2 times 5 over 2 is just 5. So I've just done the opposite of multiplying the 2 in, basically. Now we're going to turn this middle one into a perfect square form, and then we're going to multiply it back in the 2. So how are we now we know how to do this. Just divide this one by 2, so that's x minus 1 squared, so that's x squared minus 2x plus 1. How are we going to get to 5 over 2? Well, 1 can just be written as 2 over 2. And how are we going to get to 5 over 2? We're just going to add 3 over 2. And we know this part already. We just did it. So that's x minus 1 squared plus 3 over 2. And this is the part you forget about. Don't forget about your 2 at the end. You're going to want to multiply back in. So that's 2 times x minus 1 to be squared and 2 times 3 over 2. And we know those 2's are just going to cancel because one's above the line and one's below the line. So that's 2 times x minus 1 squared plus 3. And that's your final answer. So what are our critical points here? Well, we're going to change this sign and keep that one the same. So that's 1, 3. Is it a maximum or a minimum? Well, it's even, so they're both going to finish on the same side. And what side are they going to finish on? They're going to finish up because it's positive 2. And they're going to turn at 1, 3 up here. So that's here. It's going to go. So that's 1, 3. And is that maximum or minimum? That is a minimum. And so that's your question done. Now, very last one. See here, same thing. You have something in front of the x squared, so you want to get rid of it. So just take it out. 2x plus 3. So minus 3 times x squared is minus 3x squared. Minus 3 times 2x is minus 6x squared. And minus 3 times plus 3 is minus 9. So now we're going to turn this into vertex form. How are we going to do that? Divide that by 2. So that's x plus 1 to be squared. That's x squared plus 2x plus 1. How are we going to get to 3? We're just going to add 2. And yes, that's x plus 1 squared plus 2 don't forget about your minus 3. So that's minus 3 times x plus 1 squared. Minus 3 times 2 is minus 6. So critical point, Kp, and it's going to change the sign of this one, so it's minus 1, and then leave that one the same, so that's minus 6. So is this a max or a min? Well, let's draw the graph. It's going to be even, so they're both going to finish on the same side. What side are they going to finish on? It's going to finish down, negative, because it's negative 3 times x squared. So it's going to go something like, well, it's going to turn at minus 1, minus 6, and they're both going to finish down. So this is minus 1, minus 6, and is that a maximum or a minimum? You see it's the highest point, so it's a maximum. And that is your question done. So that's why you want to write equations in vertex form, is because it tells you more about the equation than just looking at it like this. So from here we can't tell what the turning point is, but if we wrote it in the complete square form, we can just tell by looking at it. So that's kind of why it's examinable and why you'd want to learn it. But yeah, those are basically all the questions we kind of ran through. We ran through a algebraic long division as well. I think that'll take too long to run through on the video, and there was no problems going through it on Monday. If you want me to do it, I can throw it into the next one. That's no problem. But yeah, so I'll see you next week.